Hello, everybody. Welcome to lesson 2. This is the beginning of probably 4 lessons here in a row that, a lot of rules involved. Make sure you understand these rules because we're going to build on these rules very quickly. All right, so here we go. What is an exponent? Well, to tell you what an exponent is, I'm going to look at x plus x plus x plus x plus x. If I put those all together, I get 5x, right? Multiplication then, right, that's 5 times x, that's multiplication. Multiplication is repeated addition. All right, well, let's look at the next thing. X times x times x times x times x. That's x to the 5th. I don't think there's any surprise there. But that's your first, look at an exponent. Exponents are repeated multiplication. All right, so terminology. So we have 2 to the 8th there. What number represents the base? The base is the 2. Okay, it's the number that's getting multiplied 8 times. Which number represents the exponent? That one's easy. Okay, what is the power? We say 2 to the power of 8. So together they are the power. All right, so I'm going to move down to a new example to develop a pattern. Patterns are huge in math, especially with this idea here that we're dealing with today. So I have columns. What I mean by that is the equal signs are basically separating the columns. My first column is a bunch of 3's with different exponents. My second column is those just 3's in the middle. And then the third column is what they're equal to, so the numbers. What is the pattern in the very first column? Okay, the exponent is going down by 1, right? Not sure why that's not writing very well. So it's going down 1, right? What is the pattern in the last column? So looking at that one might take a little more to look at here. What's happening is you're dividing by 3 each time. Right? Look at it. 81 divided by 3, 27. 27 divided by 3, 9. 9 divided by 3, 3. Okay, let's fill in the blanks using that pattern. So 3 to the 0, a lot of people think it's 0, but let's keep the pattern going of dividing by 3. What is 3 divided by 3? 3 divided by 3 is 1. All right, which takes me to, I'm actually going to skip down to big idea number 1 here. For every number a, so literally any number, any base, that base to the 0 power equals 1, not 0. So very simple here. 15 to the 0 power is 1. 3,142 to the 0 power is 1. Negative 23 over 61 to the 0 power is 1. Okay, hopefully you got that idea. Next idea is continue the pattern. Back up to the pattern thing up here. 1 divided by 3. 1 divided by 3 is 0.3 repeating, right? Let's leave it as a fraction though. 1 divided by 3. Notice a negative exponent is not a negative number. I'll write that down. Negative exponent is not a negative number. Okay, please get that through your head very, very quickly. All right. Another way of thinking of it is a negative exponent is repeated division. Okay, it might be a little confusing, but I can explain that further if you'd like in class. Let's keep it going. Divide by 3, so 1/3 divided by 3. Well, if you remember how to multiply and divide fractions, division, I keep the first fraction, change to multiplication, and change 3 to 1 over 3. And then what I get is 1 over 9. But what's another way of writing 9? Well, that's 3 times 3, right? Or 3 squared, right? So that leads to a bigger idea, which I'm going to clear everything and move down to the big idea number 2, which says for every number a, and integer n, a to the negative n equals 1 over n. Now, I'm going to try to help you remember this, and you're going to hear me say it's going to be like, that's really cheesy. That's okay. I don't care. It's going to help you remember. If there is a negative exponent, its base, make sure you understand what I'm talking about here. The base is a. Its base is not happy with where it's at in the fraction. So up here, negative n means that negative exponent means a is not happy being on top in the fraction. It needs to go to the bottom. Once it goes to the bottom, look, the positive exponent, it's happy on the bottom. Okay, we're going to practice that on the back now. So x to the negative fifth. That is a negative exponent. It's not happy. Right now, it's on the top of the fraction. What it wants to do is it wants to be on the other side of the fraction. When it does that, the exponent becomes happy or positive. Now, what's left on top? Well, there's nothing up there. I can't put 0 because 0 divided by anything would be 0, and it'd be just canceling everything out. That's not the case here. What's left on top is a 1. Okay, number 2, another negative exponent, meaning it's not happy. Right now, it's not happy this time in the bottom. So in the bottom, it needs to move. If it's not happy on the bottom, it wants to go to the top and become x to the positive 9th. Nothing left on the bottom, I put a 1, but x over 9 is this, or x to the 9th over 1 is the same as just x to the 9th. Okay, you can do either one of those, but yeah. Number 3, you got 3 different bases here. 7 is its own base. 7 has an exponent of negative 1. All right, sorry, of 1, positive 1. All right, so 7 has a positive exponent. It's happy on top. It stays there. X is not happy. It wants to go to the bottom. It's on top right now. It wants to go to the bottom. When it goes to the bottom, the exponent becomes positive. Y has a positive exponent already. It stays where it's at. Now all the exponents are positive, and we're good. Number 4, it's going to be a little tricky here. I guess this one's not too bad. 5 is the base. It's not happy. It's on top right now. It wants to go to the bottom and becomes 5 squared. There's nothing left on top, so we put a 1. Okay. Now I can simplify that further. 5 squared is 25. I know that. So I'm going to simplify that one to 1/25. There's that 0 exponent again. Everything inside the parentheses gets that 0 exponent, meaning there's nothing outside the parentheses. The answer to this one's just 1. Now that's going to, what I just said is going to make more sense on number 6. See how the negative is outside the parentheses? That's like negative 1 times whatever's in here. So I need to do that first. 22.4 to the 0 power is 1, but then I have to take that negative 1 times 1, and this answer is actually negative 1. Okay. Number 7, got 2 different bases here. Treat each one separately. A is not happy on top. It's got a negative exponent. It wants to go to the bottom. When it goes to the bottom, the exponent's positive and becomes happy. B is not happy on the bottom. It wants to go to the top. Okay, it becomes positive 4 and everything's positive and happy. We're good. 8 and 9, probably the 2 of the trickier problems in this whole backside here. So 2 to the negative 2 to the negative 3rd. All right. Since negative 2 is in parentheses, that's the base. So the base of negative 2 is not happy and it goes to the bottom and becomes negative 2 to the 3rd. There's a 1 left on top. I'm going to do number 9 at the same time. I'm not done with number 8, but I'm going to do number 9 at the same time. There's no parentheses here. That negative is actually a negative 1 times 2 to the negative 3rd. Negative 1 is fine. A lot of people think that it's not happy because it's got a negative, but negative 1's exponent is 1. It's fine. So negative 1 actually stays on top. 2 goes to the bottom and becomes 2 to the 3rd. Okay, now I'm gonna go back and finish number 8. Negative 2 to the 3rd is negative 2 times negative 2 times negative 2, which is negative 8. And then on this one, 2 to the 3rd is 8, so it's negative 1 over 8. I will tell you that I would be really, really mean on this one on the quiz and tell you that if the negative is on top when it should be on the bottom, I will count off. I know that those two are the same, but if I had an even exponent there, it would change things. So I will count off for that. We'll talk more about that one in class. Number 10, 4 has an exponent of 1, so it's happy on top. Leave it there. X wants to go to the bottom. It's not happy on top. Becomes x squared. Y is positive. It's happy where it's at, so it stays on the bottom. Okay. Positive exponent just means it stays where it's at. Negative exponent means it moves. It does not make things negative. Number 11, 3, not happy on top. Goes to the bottom. Becomes 3 squared. Notice how I'm just going literally base by base here. N, not happy on top. It's going to go to the bottom. Becomes n to the 5th. K to the 0. Whenever you see k to the 0, anything to the 0 power, basically it just goes away because it equals 1. So it's like I have, if I rewrote this problem, it would be 3 negative 2 n negative 5 over 1 m to the 4th. But we don't need to write that 1. So basically, for lack of a better term, when you have a 0 exponent, it knocks out that base. Okay. M, positive exponent, it's going to stay where it's at, which means there's nothing on top. There's just a 1. Oh, wait, I shouldn't be circling that because I'm not done. 3 squared is actually something I can simplify. So 1 over 3 squared is 9, n to the 5th, m to the 4th. Now I'm done. 12 looks awful, but if you just go base by base, it's not too bad. 4 goes to the bottom. G, happy on top, so it's going to stay on top. H, not happy, goes to the bottom, becomes h to the 1st. 2, not happy on the bottom, goes to the top. Notice I'm putting that out in front. Always put the numbers out in front. It's helpful. M, not happy on bottom, it's going to go to the top. And N, good on the bottom. Now I need to simplify. 2 to the 3rd is 8. G to the 5th, m to the 8th, over 4 squared is 16, h to the 1st, or you can just write h, n to the 3rd. Now, looks like I'm done, but I'm actually not. 8 and 16 can be divided. 8 divided by 16 is 1/2. So I have those reduced, basically reducing to 1/2. So the top 1 g to the 5th, or just g to the 5th, m to the 8th, over 2 h n to the 3rd. And that's my final answer for this one. Okay. All right, I'm going to clear that, and then I'm going to move on to the last piece of this, evaluating expressions. All right, so you have to evaluate for m to the negative 3rd, n to the negative 2nd, for m equals -2 and n equals 3. So basically, you're just taking -2, plugging it in for m, and 3 and putting it in for n. But I'm going to give you a very strong recommendation here, basically telling you simplify. Oops, annotate here. Simplify the expression before putting numbers in for the variables. Let me show you why. Let's say I don't follow my recommendation and I just put numbers in. 4 times -2 to the negative 3rd over 3 to the negative 2nd. There's a lot of negatives and a lot of things going to be moving around. It's going to get tricky. You don't want to be doing that. Let's move things around first to get the exponents positive, then plug stuff in. So 4 is happy where it's at. We'll leave it there. M wants to go to the bottom and becomes n to the 3rd. N wants to go to the top and become n squared. Now everything's positive. Now it's easier to deal with. So now 4, n was 3, m was -2. Notice that when I take a letter out and put a number in, I use parentheses. Now I'm going to do the simplification here. 3 squared is 9. -2 to the 3rd is -8. 4 times 9 is 36. That's going to be -9 over 2. I can take 4 out of both of those. So -9/2 is your answer here. The next example, 5 to the A. I'm not going to do this to you a bunch, but that's a weird one. B, not happy where it's at, goes to the bottom. I'm going to put 0 in for A and -3 in for B. So 5 to the 0 is 1. -3 to the third is -3 times -3, which is 9. 9 times -3 is -27. And there you go. And that's it. Hopefully that was clear. If not, we're going to spend some time on it to make sure you understand it later.